Alright, in this section here we're going to be talking about logarithmic functions. Logarithmic functions. And so in the previous section we talked about exponential functions. And to get started with logarithmic functions, we want to talk about finding the inverse now of y is equal to 2 to the x. So the function 2 to the x, alright, it does have an inverse. And if I were to write its inverse, we could say this. Remember, we just switched the x and the y. But remember, we need to get this as y is equal to, something or another here. And that something or another is what's known, abbreviated for the logarithm. The abbreviation of the logarithm, which I'm about to write. So this cannot be done using algebraic manipulation, and that is finding the inverse of this exponential function. Finding the inverse of this exponential function. So I'm going to write this. Y is equal to log, this is what's known as the base here, base 2 of x. Log base 2 of x, that's how this reads, log base 2 of x. And log is short for logarithm. Short for logarithm, okay? So this is going to be the inverse of this guy up here, right? Now we'd say, y to the negative 1, considering this is the inverse of this function here. Alright, now the big part of this is going to be being able to go from this form here, alright, to this form. Okay, now remember, a must be greater than 0 if I haven't mentioned that, and a cannot equal 1. Okay, so this number here has got to be greater than 0 and it cannot equal 1. Alright. Okay, so let's just give some examples here. This may not be making any sense at this point, but I think maybe it eventually will. We have log base 8, okay, of 64 is equal to 2. Now this is in logarithmic form, and I want to rewrite this in exponential form. So you see this a right here, okay, or this 8, which is our a. We're going to write this as 8 raised to the second power is equal to 64. And we do know that 8 times 8 is 64. So just remember that this number down here gets moved diagonally, let's say to right here. Right? You see that? 8 squared is equal to 64. I should have probably wrote it like this. 64 is equal to 8 raised to the second power. So just remember, you take that and move it diagonally to here. Okay, and drop the log. Okay. Alright, we'll look at some more examples. What if I had log with a base 4 of 1 is equal to 0? So we take the 1, we just drop the log, rewrite the 1, move that 4 over. Right, I'm just trying to give you a way to remember this. So we know that a number raised to the 0 power is 1. Okay? A number raised to the 0 power is 1. So I could have a 5 here, or a 6, or a 7, or whatever. Right? As long as it's not, or it's greater than 0, not equal to 1. Okay? Let's look at another one here. What about if I had log base 27 of 9 is equal to x? So bringing this 27 over, raised to the x is equal to 9. You see that? So earlier we saw